Welcome pre-calculus students to the review sheet help video. Here's the assignment right here in front of you. Be sure and have your books out, your review sheet out, your calculators, papers, pencils, and this this video will cover half the review sheet, and then I'm going to make another video that covers the second half. Now both of these videos will be posted at the same time. I'm just breaking up into two parts to give me a break, so I'm not sitting here for 2 straight hours or 45 hour and a half straight or whatever it might be. So we're going to do, I think it's 21 problems, and then I will end the video and I will let you know when course is ending, and then part 2 will have 20 problems on it. So 21 problems and 20 problems. So okay, let's go ahead and get started. Page 575. Let's look at 37 through 61 odd. Let me turn over there. Numbers 37 through 61, the directions say to evaluate. So here's number 1. What I taught you in your notes today is start inside the parentheses, and you rewrite inverse sine like this. Let me fix my pen here. I was using that for a different thing a little bit ago. There we go. So you would write sine of some angle x equals 0.3. And then bring down your sine. Now, we do not have 0.3 is not on our special table that we have of our special angles. So what I do is I hit, whenever you're looking for an angle on your calculator, you hit second sine, and then you would type in second sine 0.3, and you will get out 17.45760312. So now we know that the angle we're looking for right here is 17.4576, etc. And then bring down your sine right here, and then take the sine of that degree, and you'll get out, trust me, you'll get out 0.3. We just went in a circle. Look, students, we said to ourselves, what angle, when I take the sine of it, gives me 0.3? And then when I got that angle, I take the sine of it, which would give me 0.3. Okay? Hope that makes sense. Number 39. Okay, let's go ahead and start inside the brackets first. So cosine of negative pi over 4. Cosine of negative pi over 4. What I would recommend for you, first of all, let me get my pen working here. First of all, we're taking the cosine of negative pi over 4, which is the same thing, students, as the cosine of negative 45 degrees. Okay? It's a lot easier to work with degrees than it is to work with radians. So, sorry about that, my pen is freezing up like it always does. So I'm trying to find the cosine of negative 45 degrees. Now, we do have our table here to help us. Okay? Now, cosine of 45 is square root of 2 over 2. Do you see that? Cosine of 45 is square root of 2 over 2. But we're looking for the cosine of negative 45. So we know it's going to be square root of 2 over 2, but we got to remember it's negative 45 degrees. So cosine of negative 45, that would put us in this quadrant down here. There, I just drew negative 45 degrees. So 45 is inside of my triangle here. I went down negative 45 degrees. And cosine in this quadrant is positive. Okay? So I can find the cosine of 45 degrees right here, as long as I remember in this quadrant cosine is positive. So the cosine of negative 45 degrees is the same thing as the cosine of 45 degrees, as long as I remember it's positive. So now what I have is square root of 2 over 2. Where'd that come from? Well, I just showed you right here. The cosine of 45 degrees is square root of 2 over 2. All right? So right here, this whole thing right here, cosine of 45 is square root of 2 over 2, and then bring down your inverse cosine. So cosine negative 1. Boy, this thing's really acting up, guys, and I apologize to you. There we go, cosine negative 1. All right, now cosine inverse would simply mean cosine of what angle gives me square root of 2 over 2. Now remember, whenever you're dealing with inverse cosines, we have a boundary we have to use, and the boundary, of course, for cosine is first and second quadrant. First and second. So cosine is positive here. negative here. So what angle would give me, when I take cosine of a certain angle, would I get square root of 2 over 2? Well, guys, it would be 45. We just saw that. When you take the cosine of 45 degrees, you get square root of 2 over 2. So the angle then we're looking for is x equals 45 degrees, or pi over 4, whatever they're asking for. So 45 degrees, or pi over 4. All right, let's take a look at number 41. All right, we start on the inside, and let's see. First of all, I'm going to convert pi over 5 to degrees, and you will get 36 degrees. So first of all, I have the sine of 36 degrees, okay? So I'm going to go ahead and type into my calculator. I'm going to bring down sine inverse, and I'm going to go ahead and type into my calculator the sine of 36, because students, 36 degrees is not one of my special angles, so I cannot use my chart right here. I have 30, 45, and 60, so I have to use my calculator. So the sine of 36 degrees would be 0.5877852523. Okay? So the sine of 36 degrees would be this, and then I have inverse sine of this, so I simply say to myself, well, the sine of what angle would give me 0.5877. Guys, it's 36 degrees. It's just what we started with. Look what I did. The sine of 36 is this. Then I said to myself, okay, inverse sine, the sine of what angle will give me this? Well, it's 36 degrees. And if you don't believe me, type into your calculator. Notice right here we're looking for an angle. So whenever you're looking for an angle, you hit second sine. So when you hit second sine, up pops sine -1 parentheses, and then type in 0.5877, hit enter, and it'll be 36 point something, but you're going to get 36 degrees. All right. Okay, moving on to number 40, whatever it is, 43. All right. Now, first of all, let's remember to convert our radians over to degrees. It's a little easier. So tangent of 2 pi over 3 is the same thing as tangent of 120 degrees. So there we go, the tangent of 121 degrees. Now, that is one of my angles that I know. It is, Mr. Hart? Yeah, it is, guys. Watch. Tangent of 120 degrees, the reference angle for 120 degrees is 60. Okay? So if I'm looking for the tangent of 120, that's the same thing as looking for the tangent of 60, as long as I remember that tangent is what in this quadrant over here? It's negative. So the tangent of 120 is the same thing. Well, the tangent of 2 pi over 3 is the same thing as the tangent of 120, and the tangent of 120 is the same thing as tangent 60, as long as you remember that you're in the second quadrant, thus tangent will be negative. So what you're going to get out will be negative. So we can go ahead and take the tangent of 60, as long as we remember it'll be negative. So let's see, the tangent of 60, well, here's tangent, here's 60, here's tangent, here's 60, so it's square root of 3. Tangent of 60 is square root of 3. All right, so negative square root of 3. There we go. And now bring down your tangent -1. Tangent -1. So inverse tangent of negative square root of 3. So now I rewrite that like this. I write tangent of some angle x equals negative square root of 3. So now I'm looking for this angle right here. Well, whenever it's inverse tangent, remember, students, we have by definition restricted ourselves to quadrant 1 and quadrant 4. Now, having said that, tangent is positive in quadrant 1. It's negative in quadrant 4. And notice we have negative square root of 3, so we are going to go into this quadrant here. And so now we're saying to ourselves, all right, here's where our triangle is going to be. What angle, when I take the tangent of it, gives me square root of 3? Well, here it is. Look, guys. I'm going to move it over just a little bit. But look, right here. Tangent, square root of 3. Tangent, square root of 3, 60. Tangent of 60 is square root of 3. So I know that it's 60 degrees that goes in this triangle right here. And, of course, I rotate down. It'd be negative 60 degrees. So the tangent of negative 60. Boy, this pen's really messing up, guys. I apologize. the tangent of negative 60 equals negative square root of 3. So what does x have to equal then? Well, it has to equal negative 60 degrees. Negative 60 degrees. Or if you want, negative pi over 3, which is your radians. Okay? All right, number 45. We start off, first of all, working on the inside. So we say tangent of some angle x equals square root of 3 over 3. Now let's see if we have a special angle for that. Here's our chart. Tangent, here it is. Look right here, guys. Tangent of 30 is square root of 3 over 3. Tangent of 30 is square root of 3 over 3. Okay? So, I know now that the angle I'm looking for here is 30 degrees. Okay? And now bring down your sine. So I'm taking the sine of 30 degrees. Let's bring our chart back up again. Let's see. Sine of 30 degrees is 1/2. So the answer to 45 would be 1/2. 1/2. All right? All right, let's go ahead and take a look at number 47. All right, we start off on the inside here. We say cosine of some angle equals square root of 2 over 2. Cosine of some angle equals square root of 2 over 2. Well, let's see. Here's cosine. Looking for square root of 2 over 2. Here it is. So cosine of 45 degrees is square root of 2 over 2. Cosine of 45 degrees is square root of 2 over 2. So now I know the angle I'm looking for is 45 degrees. So what angle, when I take the cosine of it, gives me square root of 2 over 2, 45 degrees. Then bring down your tangent. So now I'm taking the tangent of 45 degrees. The tangent of 45 degrees. Well, let's see. Here's tangent of 45 degrees would be 1. Tangent of 45 degrees would be 1. All right? So the answer is 1 for number 47. All right? Let's continue on. Number 49. Okay, we start on the inside. We're going to find the cosine of pi over 6. Now, pi over 6 is 30 degrees. So we're going to find the cosine of 30 degrees. Now that we can use our special triangles for that. So here we go. Cosine of 30 degrees is square root of 3 over 2. Square root of 3 over 2. So cosine of 30 degrees is square root of 3 over 2. And then bring down your inverse sine. Now, inverse sine of square root of 3 over 2 just simply means sine of some angle equals square root of 3 over 2. So let's look at our table again. Pull it over here a little bit. Okay, I'm looking at all my sine answers here and seeing if I get square root of 3 over 2. Here it is right here. Sine of 60 is square root of 3 over 2. So what angle do I want right there? Square root of 60 degrees. So x equals 60 degrees. Or you could also put, if you wanted radians, pi over 3. And be able to do both those for the test if I ask for it in degrees or radians, okay? All right, number 51. Well, let's start on the inside. We're going to write sine of some angle x equals 0.1. All right? Sine of some angle x equals 0.1. Now, they are wanting us to use exact answers here, okay? So don't just type that into your calculator. First of all, notice on your table, look at your sine values. None of them are 0.1. It's 1/2 square root of 2 over 2 and square root of 3 over 2. So none of those are going to help us. So what we're going to do is we're going to say sine of some angle equals 0.1. Really? Isn't 0.1 1/10? So I'm going to go ahead and put 1/10, okay? Now I still don't know the angle, but here's what I do know. I know that sine is restricted to quadrants 1 and 4, and I know I've got to be in quadrant 1 because my 1/10 is positive. So watch what I do. Even though I don't know what x is, I don't know what this angle is, watch what I can do. I can still draw a triangle and admit that I don't know what x is and put x right here. And then what do I know about x? Well, the sine of x is opposite over hypotenuse, 1/10. Opposite over hypotenuse. Now you see why I did not leave at 0.1. 0.1 is not going to help me get two sides of my triangle, but 0.1 is 1/10, and 1/10 gives me my opposite and my hypotenuse. Now, using Pythagorean theorem, we should get let's see, 100 minus 1, we should get the square root of 99. The square root of 99, all right, for this side right here. Now, remember, students, again, I don't know what x is. So when I'm trying, now watch this, please, students. When I'm trying to solve inverse sine, I'm trying to find an angle. And I never did find that angle. But you know what I did do? I found a triangle. So now, even though I don't know what this angle is, I can just call that angle what? X. I never found it. And now bring down your tangent. Even though I never found that angle x, I can still take the tangent of that angle, even though I don't know what that angle is, because I have this triangle. So the tangent of x would be opposite over adjacent, opposite over adjacent. And tangent is positive and then it's quadrant. So the tangent of x would be 1 over square root of 99. Now watch what I do. We rationalize the denominator, so now I will get square root of 99 over 99. Now watch what I do next. You got to learn to do this. 99 can be broken down. Remember, 9 times 11 is 99. Do you see that? 9 times 11 is 99. Now, the reason I chose these two numbers is I know the square root of one of them. I know the square root of 9. So now I can cross off 9 and take the square root of 9. And when I take the square root of 9, that's 3. So I put a 3 on the outside. I'm left with 11 on the inside, and I still have a 99 on the bottom. Let's take a look at this again. 99 can be broken down into 9 times 11, because 9 times 11 is 99. And then I do not know the square root of 11, so I leave it on the inside, but I do know the square root of 9, so I cross it off, and I take the square root of 9, and I put a 3 on the outside. Now, look at my outside numbers. My outside numbers are 3 and 99. Please do not try to reduce 99 and 11. 11 is under a radical, 99 is not under a radical. You cannot reduce those two numbers, but you can reduce these two numbers right here. And 3 goes into both of those numbers. So this becomes a 1, and this becomes a 33. So your final answer is 1 square root of 11 over 33. And you do not need that 1 if you don't want to put it. You do not need that 1. We can just say square root of 11 over 33. Let me grab a drink of water here while you look that over. All of these types of problems on the test, I am going to expect you to have exact numbers for your answers, okay? All right, number 53. All right, we're going to take the sine of 7 pi over 6. Now, first of all, let's change 7 pi over 6 to degrees. And we're going to get 210 degrees. You need to know how to do that on your test. So 210 degrees. So next, I'm going to take the sine of 210. Now you might think, oh, I don't know what 210 is. It's not one of my special angles. Well, actually it is. If you find the reference angle for 210, you go 180 plus 30 more. So inside your triangle here, sorry about that, my pen's freezing up again. Inside your triangle would be 30 degrees. Okay, 180 plus 30 more. Now we're trying to find the sine of 210, and in order to find the sine of 210, you now know you can just take the sine of 30, as long as you remember that sine is what in this quadrant? Sine is negative. Remember, the signs go negative, negative, positive. So instead of taking the sine of 210, you're welcome to just go ahead and take the sine of 30. That's totally fine, as long as you remember you will get out a negative answer. Okay, so the sine of 210 is the same thing as sine of 30, as long as we put a negative sign. So let's look at our chart here. Sine of 30. Let's see. Sine of 30 is 1/2. Sine of 30 is 1/2. Okay, so I'm going to put a negative 1/2 right here, and then bring down your inverse sine. So sine negative 1. Now let's rewrite this. We want sine of some angle equals negative 1/2. Now, let's take a look at our table real quick if we could. When does sine give me 1/2? Let's slide this box out of the way a little bit. Take a look at this right here, students. Look, sine of 30 gives me 1/2. Now, I know I want a negative 1/2. Just bear with me. Sine of 30 is 1/2. Don't forget that, okay? So, whenever I'm using inverse sine, remember, by definition, I've restricted myself to this quadrant and this quadrant. And notice my 1/2 is negative, so I'm going to be working in the fourth quadrant. and I just saw that it's 30 degrees. The sine of 30 is 1/2. So if I rotate down and I say sine of negative 30, which is this angle here, you'll see the sine of negative 30 is negative 1/2. So the answer is negative 30 degrees, because the sine of negative 30 is negative 1/2. Or if you want a radians, negative pi over 6. Okay, we're doing really well. Let's continue on. Number 55. All right, now here we're going to start getting into writing things in terms of, like in number 55 here, we're going to write our answer in terms of a. So your answer will not just have numbers, it'll also have a variable. Now watch what happens, okay? First of all, we start off like this. We say inverse tangent, so that means tangent of some angle. And again, my pen is freezing up, so hold on one second. Wow. I wish I knew what caused this. I really, really do. Tangent, I'm using the mouse right now, so it'll be a little sloppy. Tangent of x equals a over 3. All right. Now, notice that a over 3 is positive. Okay. A over 3 is positive, and whenever we're using inverse tangent, by definition, we have restricted ourselves to first quadrant and fourth quadrant. And notice that a over 3 is positive, so I know I'm going to be in the first quadrant. Okay. And now here we go. X goes right here. I have no idea what x is, and I don't care. It doesn't matter. As long as I can label all three sides, I'm fine. So tangent of x is opposite a over adjacent 3. Now let's find the hypotenuse using Pythagorean Theorem. So leg squared plus leg squared equals hypotenuse squared. So a squared plus 9 equals hypotenuse squared. And now take the square root of both sides. So the square root of a squared plus 9 is the square root of a squared plus 9. The square root of h squared is h. So now I know the hypotenuse. I'm going to draw an arrow. The hypotenuse is the square root of a squared plus 9. Now a lot of students say, oh, well the square root of a squared plus 9 is a plus 3. Guys, that's two terms. You cannot take the square root of each of those because you have two terms under the radical. So now we know what the hypotenuse is. So look, students, did I ever solve this inverse tangent and find the angle? No, I did not. But I don't care because I have a triangle now that has angle x right here. So tangent of x equals a over 3. I don't know what x is, but now I can go ahead and find the sine of angle x. That is if my pen will let me. There we go. So the sine of x. So here's x opposite over hypotenuse. Opposite over hypotenuse, which would be a over square root of a squared plus 9. Now, I'm not going to have you do any rationalizing on these types of problems. I'm going to let you leave them like this. Okay, so this is totally acceptable. I have no problem with that. And let's continue on. Let's take a look now at number 57. All right, now what we have here is we start off by saying, okay, sine of some angle, I guess we'll call it x, equals p over q. Now notice p over q is positive, so I will be in the first quadrant. I'm going to go ahead and put my x right here, and sine is opposite over hypotenuse, so here's my opposite, and here's my hypotenuse, and that is a q, even though it doesn't look like it. All right, now, using Pythagorean's theorem, I'm going to go ahead and find this leg right here, this missing leg, okay? So, let's see. Get this pen to work again. There we go. All right, my one leg, I'll just call it L squared. That's my missing leg right here. My other leg is P. So leg squared plus leg squared equals hypotenuse squared. Now bring the P squared over and make it negative. And so next, I would have, I'm going to go ahead and go back to the mouse again. So hold on one second. There we go. So bring the P, and I'll be a little sloppy. I'm using the mouse here. But bring the P squared over. And when you do that, you will have q squared minus p squared bring the p squared over and make it negative, and now take the square root of both sides. The square root of L squared is L, and the square root of this right side would be the square root of Q squared minus P squared. So there's your leg. Your leg is the square root of Q squared minus P squared. Okay? Now, look students, when I tried to find the inverse sine, did I ever find what x is? No, I never did. But I don't care. I have a triangle that represents the angle x very nicely. So even though I never found x, I can now just simply bring down my cotangent and say, okay, I don't know what this angle is, but I'm going to call it x. And now I can find, if I can get this to work here. And now I can find the cotangent of x. Hopefully. All right, cotangent of x. Now, cotangent, if you remember, here's x right here. Cotangent is adjacent over opposite. Adjacent over opposite. So the cotangent of x, here's x. Adjacent would be square root of Q squared minus P squared. That's your adjacent over your opposite, which would be the letter P. So there's your answer. The square root of Q squared minus P squared all over P. All right? Number 59. 59. Okay, this one will be interesting. Ignore that P right there. That's just part of another problem. Okay, now this will really be interesting. Inverse sine, of course, that means we're going to look for the sine of angle x equals okay, I'm back. Here we go. So the inverse sine means sine of angle x would equal P over, I am using the mouse a lot, so it'll be a little slower, P squared plus 9. Okay, so we're looking for an angle that gives us this. Now, of course, we're not going to know that angle, but we do realize is this entire fraction right here is positive, so we know that we're in the first quadrant right here. And we're going to go ahead and call this angle x, even though we don't know what x is. And we know opposite would be P, and then we know the hypotenuse would be the square root of P squared plus 9. Let me fix that real quick. Plus 9, okay? So I'm going to try very quickly to find this missing leg. I'm going to say leg squared, that's the leg I'm missing, plus my other leg, P squared, equals the square root of P squared plus 9. Now, first of all, this is going to be a little interesting, okay? First of all, I am trying to find what this leg squared would be, right? What this leg would be, okay? This is what I'm trying to get all by itself. All right, so watch carefully. If my goal is to get L by itself, then obviously I must first bring the P squared to the other side. And if I do that, I would then be left over with the square root of P squared plus 9, and then bring your P squared over minus P squared. Notice the negative P squared is not under the radical. It's not under the square root. And now take the square root of both sides, which is really weird, but that's okay. So the square root of L squared is L, and the square root of this whole other side would look like this. The square root of P squared plus 9 minus, and I thank you again for your patience. This pen's really freezing up, guys, minus P squared. Now, I'm not going to take time and write. Well, actually, what I could do is just highlight this whole thing and just pull it up here. So now that is your entire leg right here for this, okay? Now, I never found what x was, never, but I can still take the tangent of x. So I can say, okay, bring down my tangent of x. And tangent of x would be opposite over adjacent, opposite over adjacent. So opposite is p all over the square root of p squared plus 9 minus p squared. Just like that. And that's totally sufficient. The back of the book may have taken it a little further. That's totally good for what we're trying to accomplish for this problem. Okay, we're just trying to get you used to inverse trig functions, regular trig functions, etc. So totally fine. All right, number 61. All right, now here's what we have. We have 1/2 times sine of some angle x equals square root of 3 over 2. Do you see how I did that? 1/2 times the sine of some angle equals square root of 3 over 2. So sine of some angle that would give me square root of 3 over 2. Well, here it is. Look, here's sine. Sine of 60 gives me square root of 3 over 2. Sine of 60 gives me square root of 3 over 2. So I know that this angle right here has to be 60. So now I have 1/2 times 60. And then, of course, sorry about that. Let me fix that. 1/2 times 60 would be 30. And then just simply, sorry guys, and then simply get this pen to work. Bring down your cosine. So now we have the cosine of 30 degrees. Okay? And the cosine of 30 degrees, if I can grab this and pull it over here. Well, definitely didn't mean to do that. There we go. So let's see. The cosine of 30 degrees would be square root of 3 over 2. So 61 would be square root of 3 over 2. Over 2. Here we go. Square root of 3 over 2. All right, let's continue on to the rest of the review sheet. I believe we're moving on now. Let me quickly, just give me 1 second, scan to the top of the review sheet. We're moving on to page 562. So page 562, number 6 on page 562. And I believe we're only going to do about, I think about 7 more problems, and then we'll be done with this first video. It'll be halfway done, okay? Page 562, number 6, and we are going to prove these trig identities, okay? So here we go, number 6. Okay, what I've taught you in the past is quite often when you have one fraction on one side equal to the other, another fraction on the other side, you cross multiply like this. And that's what we're going to do. We're going to take sine times secant and sine times cosecant. So I would have and what we might have to do here, students, this thing's really messing up badly and I cannot continue to do this video with this pen like this. So here's what we're going to have to do. I'm sorry, we're going to have to break this up into 3 videos. I'm going to have to go ahead and we're going to call this part right here, if you'll please look at the video. If you will look at page 575, 37 through 61, we just did that. We're going to call that video number 1. And then I'm going to turn this off and shut the computer down and try to unfreeze everything. And video number 2 will cover 6 through 50, every other odd. And then video number 3 will cover page 576, 2 through 32 even. So each video is going to be called this. Each video will be called Pre-Cal October, if I can get it to right, October 18th. Review sheet, part 1, and then pre-cal October 18th review sheet, part 2, and then pre-cal October 18th review sheet, part 3. Okay, so those will be the 3 videos. They'll all be posted on the same day at the same time, but I'm going to have to try to unfreeze this computer. I cannot continue to do this and do a good job. So there we go. Hope that makes sense. And as you listen to this, if you have any questions, don't hesitate to call or email.